and like encouraging it. And we were talking about, actually in the car, we were talking about how apparently Starbucks, they give money to Planned Parenthood. And he says that he doesn't like that because it encourages people to get abortions. But I was like, well, how are they encouraging it? They're just saying that they're just giving all the options. And he says, well, giving it as an option isn't encouraging it. And I said, I want a rigorous definition of the word encouraging. And he was like, and he didn't really say anything. So.
And he's like, well, I'm not paying for your college anymore, so there's your rigorous definition. you can buy your own food. Oh, God, this was up there. I swear that was working. Rebecca.
Okay, so for your speech and debate, is it different than the class with Miss Keating?
Miss Keating's class coincides with it, but you don't have to be on the team to be in the class, and a lot of kids on the team are not in the class.
Well, no, like I'm taking the class.
Good, you should.
Well, so far I'm really not good at it, and I really don't like it.
Well, a lot of people come in not good. We make you better.
Okay, but...
Like, it's the #1 public activity colleges are looking for. Why? Because no matter what you do in life, you have to be able to speak in front of an audience. 500 is right here. You need to go to the front office, though. Oh, okay. That's where that thing is. Thomas, I'm just letting you know that totally just happened. Anything else? Yes, go ahead.
My brother responded, and I don't think he gets it. He says, that's the slope, I think, ? What are you talking about? I need some context.
Tell him just wait till he comes back next weekend. The context will be apparent. All right, learning goal 2.1 is we need to be able to identify, and I will get an actual wording out in front of me. We have to be able to identify a quadratic function written in and A is standard form. Well, first you're going to be asking yourself, what is a rigorous definition of a quadratic function? Quadratic function. Zoe, can you remind me after I'm done writing this definition to text out the link so people can watch it that aren't here? Yes. Identify a quadratic written in standard form. Well, what's a quadratic function? A quadratic function is a polynomial function of degree 2. A polynomial function of degree 2. Thank you. This is going to take a minute, so hold on. What's up, brother? Used to yell at him a lot. What's that?
Oh.
Used to yell at him a lot.
I forgot. I'm sorry.
Keaton? No, it's not Keaton. Keegan?
Maybe you should do the first one.
What? Are you talking smack?
No.
Are you talking smack to Bonzer?
No.
I have not kicked anybody out yet this year. Miss Parnell might not think I'm even capable. She is, isn't she? Should I give her the boot? Good, all right.
Don't lie. Oh my God.
She just totally threw you under the bus. It's still loading remind. That's when I said this is going to take a minute. I wasn't lying. Like, it's just really slow. Like, this is literally how long it takes to load a website printed off. You see why I used to yell at him a lot? Oh. The sound works. Yay. All right, for those of you watching at home, here we go. Now I need to unfreeze it. There we go. All right, a polynomial of degree 2. What is standard form? It literally took 2 minutes and 18 seconds to load Remind and send the copy of the link. What's standard form? Y is equal to ax squared plus bx plus c. I should capitalize the b as well. The only condition is a cannot equal 0. That's it. So it's not like linear standard form where a, b, and c had to be positive whole numbers. Y equals ax squared plus bx plus c. A cannot be equal to 0. Now, real quick, you're an honors. Why can a not equal 0? Talk to the person sitting next to you real quick. Why can a not equal 0? Or what calamity would happen if a did equal 0? Volunteer, what would happen? Volunteer, what would happen? Brian,
Get a linear function
why would we get a linear function?
because there's you got rid of the beginning and there's no degree.
Right, suddenly the degree would be what?
1.
1, right. So yeah, it has to, that's why a cannot equal 0. What else can we take a peek at? That's it for right now. Let's also talk about A is standard form. B is in vertex form. What's the vertex form of a quadratic look like? Y is equal to A times the quantity x minus h, quantity squared, plus k. Bless you.
Thank you.
And what do you need to know about this? Again, a cannot equal 0, and h comma k is the coordinates of the vertex.
Wait, what does it say? A
A cannot equal 0.
No, the equation. Y equals A.
A times the quantity x minus h, quantity squared, plus k. All right, third version. C is in factored form. Y is equal to some constant k multiplied by x minus a times x minus b. All right, there's 3 forms. D of our learning target is in a table of values, but I'll give you a second. A couple you're still copying. While I'm doing that, let's ask a good question. X minus A times X minus B. That would appear that it's of degree what? 1. Talk to the person sitting next to you. Is that a quadratic, yay or nay? Is that a quadratic, yay or nay?
Yeah, because there's 2 x's. Once you like do the what's it called?
What's the vocabulary word?
Do you remember the vocabulary?
Parabola.
No.
It
like
throw something out.
For whatever. For when
Use
you
it in a
like
sentence.
I wanted to fenestrate myself.
no.
Fish tail.
You
Nothing.
want to throw
Did you
yourself
guys
on
do the fish
Yes.
tail?
No.
Oh.
All right.
I think my brother's really confused.
Tell him I'm exceptionally disappointed in his lack of rigorous vocabulary.
He asked, is this for you or me? And then, are you in class right now?
Tell him you're in Beckman's class, and Beckman's extremely disappointed in you. All right, volunteer. Is this quadratic, yay or nay? Is this quadratic, yay or nay? Yay. Okay, I need a volunteer though. I hear several yeses. Why? Yes. Who hasn't talked to you today? Bird. Why?
Because when you multiply with the parentheses, you're going to end up multiplying x by x, and that will give you x squared.
Boom. And I even like better how she didn't use a word that's not a math word like what? So yeah, FOIL. No, that's not a math operation. Foiling is just what? Yeah. It's an acronym of what operation though? Distribution, right.
Distribution.
It's just distribution. And somebody said multiplication. It is multiplying more than one term. If you've got 3 times a parenthesis with 2 terms in it, you got to distribute the 3 to each one. When you've got a parenthesis with 2 terms multiplied by a parenthesis with 2 terms, you must distribute both of those terms to both of the terms in the other parenthesis. It's just using distribution. FOIL is a special case of distribution. But all you really need to say is we're distributing it. Okay, so that's why it'll be an x squared. The same thing in the vertex form. When you have x minus h quantity squared, that's equal to x minus h times x minus h distributed out, we'll get a square term. Okay, D is in a table of values. This one I got to show you a little bit because we got to get a definition up there. I got to show you a little bit first. So a table of values.
What's the four?
Wait,
Yeah.
Yeah,
4?
what's the 4 for?
Table. Oh, what did
No,
I put
D.
before? That's a
D.
D. That's a
What?
D, duh. And I've got to mooch my notes here. So we got -3, -2, -1, 0, 1, and 2. And let's go for y values of 16, 13, 10, 7, 4, and 1. Now here's what I would like you to do real quick on your own. What is the rate of change? What is the rate of change that our y values are experienced as x changes? What's the rate of change on this puppy? Or what's our difference?
On the X or the Y?
The y.
Okay, then it is.
That's a little
Me and Max are like great friends
Good.
now.
Good.
We snap all the time.
All the time.
We're gonna be like best friends.
Best
I
friends.
warned him. I said, sorry, you're probably gonna get annoyed with me, but we're gonna be
She
best
talks
friends.
a lot. Good thing. You must be a good listener.
Mhm.
Good job. Do you know that's the number one thing that women look for in a future husband? Good listening. All right, volunteer. I need a rate of change, or I need our common difference. What is our common difference of this one? Somebody want to talk to you today. Somebody goes, Evan, you looked at me at just the right time. Talk to me about common difference of this puppy.
It is a common difference of the y value is -3.
Yeah, because every time x goes up by 1, what's y going down by?
3.
Okay. 3, 3. Okay, is this a quadratic relationship? No, it's a what? Right, this is a linear relationship. But we need that to compare and contrast what we're going to find in a quadratic relationship. So this is a linear relationship that has constant rate of change. Of course, constant rate of change is the slope. That's y2 minus y1 over x2 minus x1, which is really all you've done here. A duck question real quick. If my next value was 4 on this table, what would my next y value need to be to keep that constant rate of change? Give you 8 seconds to think on your own. If my next x value was 4, what would my next y value need to be? What would my next y value need to be?
My brother said that he just commented on your live video.
On my what video?
On your
Live.
live video.
How do you get into your line?
I sent you that link?
No, her brother.
Yeah.
Because he followed it. Like, he was in my class last year, so you just subscribe to my
Oh.
YouTube channel, and then every time I upload a video, it sends you a notification.
YouTube
So-
channel. I love it.
Yeah, we're streaming. You want to say hi to all the kids watching that are sick today?
Hello, everyone that's homesick today.
Yeah, we're missing.
What kind of math is this?
Honors Algebra
What kind?
2.
Algebra 2.
What's the learning target we're working on right now?
Identify the quadratic function. Written in standard form, vertex form, factored form, and a table of values.
Yeah, you would. There you go. All right, let's take a look at how this difference between a quadratic. I'm going to give you one. I'm going to tell you it's quadratic. Then I'm going to show you what it means to have a quadratic relationship. Let's go for -3, -2, -1, 0, 1, 2, 3. And by the way, too, if I do anything dumb today, I stayed up late to watch the Broncos. I kept thinking, okay, the Broncos are going to be good any moment now, which of course lasted until they finally looked decent in like the last 4 minutes of the game. And then for some reason I just stayed in bed and like just stared at the ceiling all night. So slept like 8 seconds. So if I do something dumb, please let me know. Which is why I'm having to consult my notes today. Okay, so then here's my y values. -11, -10, -7, -2, 5, 14, 25. These are just the problems Packer fans are not having right now. Okay, here's what I would like you to do. Find the common rate of change. Find the common rate of change, because you know we're going up by 1 over here. What's the common rate of change?
is degree 1. It has to be the same.
All right, let's look real quick.
And
To go from
second
-11 to -10, that means we went
2 plus 1.
from, and then we went,
Plus 3.
okay, need more participation. Then we went,
Plus 5.
anybody seeing a pattern?
Plus
Okay,
7,
then up,
plus
7.
up,
9,
up.
plus 11.
That's not a constant rate of change, though. Ella.
If you go from plus 1 to plus 3, that's plus 2, and then it's for all of them, and that's a constant rate of change.
Yes. This is called our rate of change, the first degree of our rate of change. This is the first degree, which is constant in a linear function. The first degree is a constant rate of change. In a quadratic, the first degree varies, but the second degree is constant. In other words, the rate of change of your rate of change is constant. The rate of change of your rate of change is constant. Yep, let me finish writing real quick. The second degree rate of change is constant. The second degree rate of change is constant, which kind of makes sense. A linear equation has a constant rate of change. Its slope. A quadratic equation has a constant acceleration. Like if you've ever graphed a parabola back in the glory days of Algebra 1, the slope is not constant, like you could if you drew a line tangent to the graph, but the acceleration of a quadratic is constant, which is why the second degree rate of change is constant in a quadratic. Questions? I saw one back there. Anderson, yes?
Okay, so the quadratic, always, table of value for quadratic always has to have the second be constant, not the first?
Correct. If it's first, it's a linear. If it's second, it's quadratic. If neither one are constant, we have neither of the above right now. Other questions? All right, let's play a fun game. Linear, quadratic, or neither? Linear, quadratic, or neither? Linear, quadratic, or neither? All right, so number 1, you're going to label this as linear, quadratic, or neither, and explain why. -2, -1, 0, 1, and 2. And let's go 4, 6, 9, 13, and 21. Let's go for number 2. -2, -1, 0, 1, 2. And then let's go number 3. Okay, there we go. Beneath each one, linear, quadratic, or neither. Linear, quadratic, or neither. Linear, quadratic, or neither. Ready, set, go. Those of you at home, too, don't forget, you can actually send questions into class, or you can submit your answers, and I'll tell you if you're right or not, just by sending a reply to one of the remind texts, and I will totally watch it. I get it on my phone, and I will reply back with how it's good. Linear, quadratic, or neither. totally talk to the person next to you too. Take a look at these puppies.
First one, it seems like it should be. Because this one goes.
No. You got to check it for the whole thing. Don't check it for some small set of data. You check, claims got 4 inches, you check 2 of them, you're like, it's good to go. Don't go and check all 4. Yeah, keep checking the whole thing. Just because it starts out that way. Are your teachers that boring that they let it start out looking like it's going to be the right answer and never play a fool on you? Well, this teacher's not that boring. I like to come up with exotic problems. All right, you got it. Still copying? Why not?
Because
No, I got it. It's minus 2 plus 2.
Oh,
Okay.
minus
Yeah,
two.
the last one played on.
Neither, because
Okay.
we're constant in the
That's a
second degree,
minus
that would be quadratic.
Okay, good. Talk to each other. Work with each other.
No, because it's
Make a
plus
friend.
6.
When you see each other in the hallway, now you know somebody.
For the first one, yeah.
Plus 2 plus 0.
I mean, you can talk about the day you said, man, I sat next to you in Honors Algebra 2. Remember that day that Beckman was talking in secret code to Ella's older brother about how he wanted delta x to be equal to 0 between her and her date at homecoming because he was a senior boy? Or he didn't want them to get arbitrarily close? Exactly, but that's why she's got a brother there to help her make good choices.
What?
I make decently good choices.
I'm sure that makes your mom feel good every time you leave the house with him. Like, Mom, I'm going to make decently good choices.
Okay, I make good choices except for there was a bad person in the past
Okay.
that I didn't make good decisions.
Was it a senior boy?
No.
Okay. Was he a junior at the time and now he's a senior boy?
No.
Okay, good.
But he was a sophomore when I was a freshman.
So this older boy thing hasn't had a great track record?
No. Well, because when I was a freshman, I also had a junior.
Oh boy. Trying to think, where is it?
And-
Yep, there it is right there, number 1.
But no, you know
Yep,
what the
there's
crazy thing?
22.
The junior, when I was a freshman, he was friends with John. Isn't that kind of?
That's awkward.
Yeah,
That's
it was
weird.
awkward. But
Yeah, they knock on your door and you don't know which one they're there to see. Yeah, that is awkward.
no.
Like your brother's like, what's up, brother? You haven't came over forever. And he's like, oh, I'm here to see your sister.
Yeah.
And he doesn't know whether to be mad or disgusted, like which emotion to feel.
Yeah.
All right, volunteer, come on up and show us what you got for these 3. Volunteer, besides telling us she's already talked today. Kate, you look like you want this one.
I didn't write them down, but I can explain it.
Yes, you have to explain. We need to know why you're intelligent, not just that you're intelligent.
Okay.
You want it? No, you got to come up and show the internet. Justin Bieber may be watching this video. We want him to see
-6
your incredible
0
results
is
here.
plus 6.
Do we though? I don't want
What?
Justin Bieber, do we really want him to see this?
Can I just like write on the list?
Yes, of course you can. Kate, in theory, I already know how to do this. You can totally write on my notes.
Alrighty.
You hope.
Okay. Okay, so for the first one, when finding the rate of change of your y values to your first degree, you get this. And then that doesn't fit the definition of a linear equation.
Okay.
So then you find your second degree rate of change values, and
Sorry, I'll text that when I get done.
that also does not fit the definition of a quadratic function, therefore it is neither.
Kate, I already know how to do this.
Okay, therefore it
Teach
is
them.
neither.
Then you stop and you say,
Do you have any questions?
nope,
No?
What questions do you have?
What questions do you
because
have?
we expect you to have questions, because that's how you get
Smarter.
smarter. Exactly.
All right. For the second one, for number 2, you find the first degree rate of change, which is that, and since they are all the same values, which is -7, that is a linear function. what questions do you have? Yes.
I actually have it about number 1.
Oh, yes.
Do you know what type of function it is? Other than neither linear or quadratic?
Nope. No, I do not.
It does not fit any of the definitions we have yet, so no.
Okay.
And I will tell you, it's a polynomial, but that's the only detail we could determine about it.
Okay.
And for the last table of values, I again found the first rate of change, the first degree, and then that's your first degree, and that does not fit the definition of a linear. So then you find the second degree, in which it would all be -2, which makes that a quadratic function. What questions do you have?
Who's my leader in this class?
I don't think you.
I didn't appoint anybody? Yeah, I was like, there's no way I didn't appoint anybody. Yeah.
Like the 1, 2?
Yeah.
Okay. 1, 2.
That was
was
terrible.
awful.
Anderson, do it again.
Okay. 1, 2.
Now, Anderson, you have to tell them what to do. You have to say, Kate, good job. Give them
Kate,
1 on 3. 1, 2.
Good job, everybody on 3. 1, 2.
Okay, good job. Questions on that?
Oh, on 3. I get it.
On 3, so you clap on 3.
On
All right,
3.
now let's budget cut. Save a little paper. Identify if number part A, is this a quadratic equation, yay or nay, which you do have to answer. And then part B, what form, if any, is it in? What form, if any, is it in? And so next time you remind me to hand my papers to people at the bottom. Talk to the person sitting next to you. They are your number 1 asset in this class. Number 1.
Okay, so number 1 is, yeah, it's a written form. And number 2 is standard form.
It's in fact or
Oh, yeah,
Does
yeah.
there have to be a K in fact? I don't think so.
There's
Well,
not.
Number 4.
Well, the K
Well, K
could
could be.
1.
Well, right.
Oh,
Yeah, K could be 1.
Number 4.
Quadratic and vector form.
Yeah.
Give about 30 more seconds. Talk to the person sitting next to you.
it's in what
Three is
standard.
All right, volunteer number 1. Volunteer number 1. Somebody, you've talked. Jessica, you haven't talked yet, right? Okay, Jessica, number 1. Is this quadratic?
Yes.
What form is it in? Which form is it in? Vertex form, right on. Vertex form. All right, number 2, another volunteer. Number 2, another volunteer. Max.
It is.
Okay.
It's a quadratic function, and it's in standard form.
Okay, but where's the C value?
You don't need one,
Why not?
because the only thing it can't have an a value of 0.
Right. Good job. All right, number 3, volunteer. Number 3, Gwyneth. Number 3, is that a quadratic?
No,
Why not?
because it's a linear equation.
Because it's of degree.
Degree 1.
Right, good. That's the definition of a linear function, a polynomial of degree 1. Good job. So, do we need to answer part B? No, it's not a quadratic. Number 4, volunteer. Little tricky. I heard a lot of talking about this one. Number 4, Zoe, what do you think?
It is quadratic.
Okay, hold on just a second though. X minus 2, I feel like that's degree 1. And x plus 3 is also degree 1.
Well, if you distribute it, then the x multiplies by the x in the second parentheses and it becomes x squared. So
All right.
it's a degree of 2.
Gotcha. Okay, what form is it in?
Factor form.
Good job. Mr. Breebach, yes.
You have a math teacher in front row or what?
Dude, we are teaching, that is one of my goals for this year, like goal. We are going to kill all of this.
Spoken.
We are going to kill all this unrigorous vocabulary and learn how to talk math and algebra too, so the pre-calc teacher doesn't.
That was well spoken, wasn't it?
I know, wasn't that like? Doesn't she sound like insanely intelligent? You know exactly what she's talking about, not like, well, the thingy is 2, so obviously this is a quadratic. You're like, which thing? All right, number 5, volunteer. Number 5, somebody doesn't talk to you today. Jordan, I think for the first time ever, I get to call on you in the second half of class with that. Quadratic, yes or no?
I said yes, and I said it's standard.
Okay, what's B and C equal to in that case?
1 or 0.
What's B and C equal to? 0, right. What's A equal to? 6, right. But B and C, the fact that they're 0 is okay. The only condition, as Max already told us, is A cannot equal 0. Stop and check up. Questions on that? Yes, Rebecca.
Doesn't B need an x though?
Doesn't necessarily. B can be 0.
So it would just be 0, like an invisible 0x is there?
Yeah, there is. Are you ready for this? You ready for this, Anderson? I'm going to blow your brain apart. You wrote y equals 6x squared.
Yes.
What you should have really wrote is that's y equals 0x to the infinity plus 0x to the infinity minus 1 plus 0x to the infinity minus 2 dot 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 plus 6x squared plus 0x plus 0 plus 0x to the no, it can't have x to the negative 1. Why not?
Because it's 1.
Right, no.
Wait,
Why can't it have 0x to the
no. 1
negative 1?
over x.
Because you can't.
In a polynomial, right. All the powers have to be positive. So literally, Rebecca, there are trillions of powers of x to the left of 6x squared that all have a coefficient of 0 and
To the
0x.
left of it?
What's that?
To the left of it?
Yeah. 0x to the infinity plus 0x to the infinity minus 1 plus 0x to the infinity minus 2. And we'd have zeros as coefficients all the way up until x squared, which has a coefficient of 6. So there are actually an infinite number of terms that have a coefficient of 0. But for it to be a quadratic, it must have a coefficient in front of the x squared term that's not equal to 0. And obviously that must be the biggest degree for it to be a quadratic. Because degree is defined as the largest exponent of the polynomial. Other questions? Zoe? Mr. Breebach's very hard to get a compliment from. So when he gives you knuckles, Mr. Breebach and Dr. Watkins, who you'll have after me, they don't dish out compliments very easily. But they love kids walking into pre-calc talking rigorous math. So just FYI, when you walk in the first day next year, like remember to flip that switch on. Questions from you all? All right, that's the end of the first target. Talk about hitting that target, you got to be able to tell if it's quadratic, tell what form it's in, and then be able to tell from a table of values if it's quadratic. Questions on cleaning that puppy up? Questions on cleaning that puppy up? All right, you know how you do something, you think it's a good idea, then you go back later and you're like, man, I got a better idea now? It's a much better idea for us to cover Learning Target 2.4 next. So we're going to cover Learning Target 2.4 next, even though I know for you that's not what order they're in. So I'll give you, no, we can go. Take out your graphing calculator too if you don't have it out right now. If you do not have one with you, please come borrow one from me because we're going to do a little exploring today. Learning target 2.4. I have one right here. And I have one right here. And don't forget, if you need a calculator, I got forms for you. We check them out for you for free. We still got some left. Also, don't forget, homecoming's next week. Perfect time to get that. You know, when the guy or the girl picks you up, they give you a calculator. Might make your older brother put his shotgun away. You know, have better feelings about that. Also, Columbus Day is coming up. Halloween, All Saints Day, Kwanzaa, Hanukkah, Christmas, Thanksgiving, Pearl Harbor Day, 9/11 is tomorrow. All perfect excuses. Jesus, I don't know what, that's Christmas. 9/11 is tomorrow. What better way to celebrate America's freedom and independence than getting a graphic calculator from your boyfriend, girlfriend, or parents? Like, there you go. What do your parents get you for 9/11?
Nothing.
Change it. Go home tonight and give them 3 really good reasons why they should get you a color graphing calculator for 9/11.
They give me years of the 9/11 GI Bill to pay for my college.
Okay, that's a good deal. Don't risk that.
I know, yeah.
All right, so 2.4 in learning target 2.4, we are going to be able to describe the transformations of a quadratic function in part A from vertex form. So I'm going to show you the whole shooting match of vertex form, even though previously we just learned about A, H, and K. The whole shooting match is y equals A times the quantity B times the quantity X minus H, that quantity being squared and plus K. And we are going to dissect these puppies one at a time. We're going to look at H. We're going to plug some numbers in for H. We're going to substitute some numbers in for H. We're going to see what it does. We're going to substitute some numbers in for K. We're going to see what it does. We're going to substitute some numbers strategically in for A and see what they do. And then we're going to substitute some numbers in for B strategically and see what they do. Notice 2 of them you can really figure out on your own. 2 of them I'm going to have to set you up for success. Give me a second to finish copying. See people doing that. So in other words, I'm going to give you an equation in a little while, and you're going to tell me the transformations that have occurred to it. But we're going to figure out what these transformations do first instead of me just telling you. You guys are smart. You can figure this out. Our parent function. Sort of like you look a lot like your parents. The simplest quadratic we could have is the parent function. What is the simplest quadratic we could possibly have? Volunteer.
Sorry.
Simplest quadratic we can have is somebody who hasn't talked yet today. Simplest quadratic we could have. Max, I think you've already talked today. Anderson, I think you've already talked today. Alex, what do you think the simplest quadratic would be?
Y equals 1, quantity x.
Simpler. Y equals x squared. Yeah, that's the simplest it could get. Y is equal to x squared. Now, I'm not ready to talk about A, B, H, and K. That's the simplest one we have. So I love the color graphing calculator because it makes it really easy to see what's going on. Really easy. So here's what I want you to do. We're going to get it ready for success. So turn this baby on. Go to y equals. Notice I've got some stuff in there, some numbers that should look familiar because I was grading your quizzes earlier today. Clear everything out of y1, y2, y3, 4, 5, 6, 7, 8, 9. And I'm going to tell you, we're going to plot functions today. Do we need to have our data plots on? No, we are going to plot functions. We do not need those puppies on. So if plot 1 is highlighted, here's what it would look like if it was highlighted. We just shut that bad boy off. So go up to plot 1 where it's flashing, turn that baby off. Turn that baby off. Here's what I'd like you to do. In y1, I would always like you to have x squared. And now, let's do some exploring. We're going to explore 4 things. We're going to explore, but we're going to first explore what k does. We're going to first explore what k does. What we're going to look for at the end of the day is what are the roles of A, B, H, K, and what do they have in common with each other? ABHK, and what do they have to do with each other? So we're just going to look at y equals x squared plus k. Here's what I would like you to do. In y2, give me a second. Sorry, I'm just so anxious to get there. It's so fun to see the math in action. Anybody need a calculator still? Everybody got one? I got more to loan. I want you to have one today, though. And remember, your first troubleshooting person is who?
Your partner.
Person sitting next to you, because if you got a decimal or something wrong, I don't want to have to for you to wait 5 minutes. The person sitting next to you is going to be your best partner for success in this class. You don't have to get married; you just have to work together in math.
Dang it. Max seems like such a nice
Didn't you just
person.
tell me about some senior boy?
I know.
Okay, it's hashtag awkward. Hashtag awkward. All right, here's what I'd like you to do. I'd like you to explore with some values of k. Some positive, some negative. But I want to show you how I want you to go through this. I want you to go, well, let's pick out a number. Who hasn't talked yet today? Ian Bates. Give me a number between negative 10 and 10. 5. I want you to look at x squared plus 5. So in other words, k is equal to 5. Then, are you going to hit graph or zoom? Zoom. I want to introduce you to a new friend. This is called Zoom Fit. Zoom Fit. What does Zoom Fit try to do? It tries to fit all the important things into one screen. Really, it tries to fit as much as it can onto one screen. So go to Zoom Fit, hit 0. There's the axis it shows. There's our original function there. And ta-da, there is our new function. Okay, we notice some things going on. Notice some things going on. You may even use the arrows to figure out, okay, that was there, now it's there. What's the difference in the points? Like, where did it move to? Okay. Okay, you may even want to look at the table. Go second table, but you don't want to do that. Second table. You may even want to look at some things, see if you can see any patterns in there. Here's what I'd like you to do. I'd like you to try 3 different values of k. And then I would like you to write a sentence to me on what k does to our parent function. And I would like you to use math words. So for those of you that took honors geometry at the high school last year, we did that wildebeest project where we talked in depth about transformations. We need to use transformation words. What are some of the transformations we learned about? What are some of the transformations we learned about? Max?
Dilation.
Dilations, whereas we multiply it by a scale factor. Okay, Bethany?
I actually just have a question.
Okay, but tell me a transformation first. Like, what if you just move it left, right, or up, down? What transformation's that? Somebody help her out. Translation. Yeah, translation, right. It translates it. It just like moves it left or right or up or down. What's another one? Yep, Eden. Rotation, right? Where you take it and actually rotate it. Jessica. Reflection, where we like reflect it over an axis, like over a mirror. Kate. Distortion, where we like multiply it, multiply part by one and another part by another. Jordan? Stretch, yep, where we just like stretch it out further away from an axis or compress it closer to an axis. So I'd like you to try 3 different values of k, then write me a sentence on what k does.
We both tried to figure it out.
Yep, that looks beautiful. Yep. Yep. It's one of those District 49 calculators. Hold on, hold on. Right, throw it in again, try it again. If that does not work, you just go to Zoom. You guys playing the same games? Oh, Hub. You got Hub on here. Yeah. Did this from last year? Oh, good. Did she download games on here?
No,
Did you talk to Mohit Bhagan connected to some weird Russian server? I know she didn't answer that question. Do you know who Mohit Bhagan is?
I know.
Did he ever hang around with your sister? Boy likes to talk a lot, doesn't he? A lot. You follow him on Instagram, he just has pictures of walls. Like he just goes around places and takes pictures of walls. All right, try it again, Fractal. If that does not work, hit Zoom. Did that work after I fixed it?
Yep.
Okay. Games change settings on things. Sometimes you just gotta reset it. Yep.
Did he talk? Then he
What's that?
Do you tap on
Oh God, yes. Mohit sometimes will just get up in class and just start walking. Right? Start walking. Yep. What is this game you all are playing that's doing this? Did you get this from your sister? Okay, go to Zoom Standard. Zoom 6. That should fix it. That's just weird that so many of yours are doing that. Now, I can't. Sure. So everybody says it connects it to Russian servers at night. Now, in Zoom Standard, it goes from -10 to -10 on both the X and the Y axis, so it's not going to show you +20, so you just got to try smaller than that. Again, go to, okay, if you are getting, let me show you what Linnea is getting here. I don't know what all rogue Russian server you guys have been downloading stuff off of. Yeah.
I don't even know how to do that. I wish I was kidding, but I can figure out numbers, but I can't do this. I don't know.
Can you do a linear regression equation? Good, that's the learning target of this class. We'll teach you all this. Can you convert decimals to fractions?
Yes.
Good. See, that's all you need to know. Like that is fancy stuff. If you go show your friends in middle school how to do that, they're going to think you're the smartest person ever to exist. So go to Zoom Standard. If it's giving you that, I don't know why it's giving you that, but go to Zoom Standard. Zoom 6. If you're going to go to Zoom Standard, make sure you choose K values between -10 and 10. Preferably smaller will help out better. Preferably the smaller, the more visible it will be. But again, remember, I want a what at the end of the day? A sen
10.
about what K does to the parent graph. What's up?
What am I supposed to? I couldn't tell if that was the thing you were saying to him. I couldn't see.
No,
Is it
it
like
wasn't. It's like
mine is all squished together.
No, that's okay. That's what it's supposed to do.
Because wait, it's fixed now.
It was still thinking about it, brother. It's not that fast.
No, earlier
yeah,
they were all
it was like
squished
they
together.
were like right next to each other.
Works now. Are you guys back tonight? Are you guys coming back tonight? Tell Mr. Carpenter I said hi.
Oh yeah.
I will text out the homework. So just so you know, we are at 45:02 for the video right now.
Yeah.
Oh,
Because we leave at 20.
Okay. Those of you leaving right now to go to band, we are 45 minutes at the video. 45 minutes in. All right, I need a sentence. Volunteer. What does K appear to do? It appears to Mackenzie.
Change the Y value of
Which one of those transformations does it do? Translate, rotate, stretch, compress, or dilate? Right. K translates y equals x squared. K units. Oh, vertically or horizontally, Mackenzie? Vertically, right. K is a vertical translation. It moves your graph K units up or K units down. Yep.
But what if when you like multiply and divide?
The only operation K does is add. The multiplication and division would be A. But we're going to be very strategic about A. You want to do A next?
Yeah.
Good, let's do A next. That's like perfectly exactly what I want to do. Number 2, we're going to explore A. Now, I will tell you, there are 2 different right answers from just looking at the graph. I'm going to tell you the right answer has the word vertical in it. The right answer has the word vertical in it, which I'm giving you a hint because you cannot tell if it's like a horizontal compression or a vertical stretch that look the same. You can't tell if it's a horizontal stretch or a vertical compression. They look the same. So I'm telling you the answer is vertical. All right, so you're going to look at y equals a multiplied by x squared. Here's what I'd like you to do. I would like you to try some when a is negative, when a is between 0 and 1, a is between 0 and 1, and when a is greater than 1. So I would like you to explore some values of a. I would again like a sentence, but I'm going to tell you this one's going to fall into 3 buckets. They're the buckets. You tell me what happens when a is each one of those values. You tell me when a is each one of those values. Were any of those people that left borrowing one of my calculators? Hope not.
We teach x squared as y1.
Of course, yeah. Yep, because that's your parent you're comparing it to. That's like what you're comparing this evidence to see how it changed. So keep y equals x squared in your y1, and then try some different values in y2. If you really feel like being a risk taker, like put 1 in y2, 1 in y3, 1 in y4, and then try to figure it out after that. Again, smaller numbers are better than bigger numbers, just so you can see them on your screen. So values between -5 and +5. Not that you can't try bigger numbers, but that will be more behaved for you to see what's going on. That and that. Again, those of you watching on the web, and I noticed I've got several viewers right now, please, you can just reply to the remind, and it totally pops up on the screen. I can see what you're asking.
That's pretty cool.
We want to end this with a sentence. Sentence. Right. When A is negative, what appears to be happening? Volunteer. When A is negative, what appears to be happening? Talk, talk, talk. Zach, were you up? You want to take it?
Yeah.
Yep. What happens when A is negative? It seems to be...
The graph reflects off the x-axis.
Right. When A is negative, reflects y equals x squared over the x-axis. Okay? What happens in between? Now we need to add in. I put this here, but I'd like you to put a couple lines there. When the absolute value of A is between 0 and 1, and when the absolute value of A is greater than 1. Because if it's negative, that's what it's going to do. So it's first going to reflect it, but it's still going to have an effect on the shape. When A is between 0 and 1, what's it going to do? Volunteer, anybody now. When A is between 0 and 1, what's... Yeah, Ella.
It's gonna, like... It's gonna stretch...
Yeah, remember I told you the right answer had the word vertical in it. So it's going to vertically do what?
It's going to vertically, stretch.
Okay, so I'm going to put up there. Blue is my original. Red is my parent. Vertically, which is the y values are vertical, Is it stretching or compressing?
It's
Is it taking him and moving him farther away from the axis or compressing him closer?
compressing.
Right. When A is between 0 and 1, it is a vertical compression by a factor of A. Vertical compression by a factor of A. So if A is equal to 0.25, it's a vertical compression by a factor of 0.25. Okay, last one. When A is greater than 1. When A is greater than 1, it is a, I told you the right answer is vertical in it. Vertical stretch by a factor of A. It's a vertical stretch by a factor of A. Let me ask you a question. Vertical, is that affecting X or Y values? Vertical stretching and shrinking, is that affecting X or Y values? Kenzie? Y. Translating vertically, translating K units vertically, is that moving stuff, is that changing the X value or the Y value? Y. Notice both of these. And notice how I kind of baited Rebecca Anderson when she said, well, do you want to cover A next? I was like totally making it like she chose it instead of I chose it. Both A and K affect the Y values. They both affect the Y values. So again, going back to this giant translation equation, A and K, notice how they're both outside the parentheses? And those of you that had me last year, you heard this over and over again. Notice how they're both outside the parentheses? They affect the Y values when they're outside the parentheses. So both A and K affect Y values. Multiplication is stretching. Addition and subtraction are translating. Multiplication is stretching. Addition and subtraction are translating. Okay, stop and check out questions so far? Yeah, of course. Remember, I got audiences at home that are watching as well. Stop and check out questions. Keep exploring, or do you need a concrete example? That wasn't helpful. Okay, I'm going to keep exploring then. We'll come together at the end. Okay, now on the inside I got to be strategic. So I'm going to show you, I'm going to tell you the values to substitute in. Number 3, we're going to explore H. So I would like you to keep y equals x squared as your first, and then I would like you to try these different ones. Y equals the quantity, x minus 2 quantity squared. Y is equal to x plus 3 quantity squared. Y is equal to x minus 4 quantity squared. And I would like a sentence. What does H do very specifically to the graph of our parent function? So I'd like you to try those 3. Look at that one first, that one second, that one third. Write me a sentence about what the role of H is. What is the role of H? Ready, set, go. Everybody out loud together. I'm going to ask a question. Y equals the quantity x minus 2, quantity squared. Translated at how many units? Terrible. Translated how many units?
2.
To the?
Left.
Right. To the right.
Okay, people, it either went to the left or to the right.
I went to the right.
Left.
You need to check your graph real quick. Check your graph.
To the right.
Y,
Because negatives
y
make
equals
it-
x minus 2 quantity squared. It either went to the left or to the right.
Went to the right.
Let's try this again. How many units?
2.
To the right or to the left?
To the right.
Let's look. We got disagreement on this one. X squared is in blue. The quantity x minus 2 quantity squared. Let's look. Oh, sorry. Oh my goodness, I hate graph. Don't do that. Don't do that. I know. Center, chicken dinner. You can kind of tell here, but let's go zoom standard. Here's my original graph right here.
Shouldn't we do zoom?
Well, some of you that's not working, so I'm working with what works. There's our original equation. Red is our translated equation. It moved it 2 units. What direction?
Right.
Which is kind of odd because it's x.
No, minus 2.
Huh, that's kind of odd. Question, what's h equal to in this case? H is equal to 2, but it moved it 2 to the right. Okay, minus 2, 2 to the right. What about plus 3? Moved it how many?
3.
To
Oh,
the
'cause it's
left.
minus.
minus 4 quantity squared moved it
4.
to the,
Right.
which is kind of weird because minus usually means to the left. Elena, what are you thinking?
Well, it moves to the right because it, in the equation is x minus h, not, so if you have a negative, it makes it.
Right, so here's what I need you to fill in real quick. If h is greater than 0, if h is less than 0, what happens? If h is less than 0, if h is greater than 0, what happens? Then you might also kind of think, why is that odd? Like, not what I expected to have happen. Not what I expected to have happen. Right, if h is greater than 0. Sentence. If h is greater than 0. Yes, Ella.
If h is greater than 0, it translates to the left. Why?
How? If h is greater than 0, so we'd be having a positive number here, so it'd be like x minus a number, translates h units to the...
left.
Don't talk
Right.
yourself out of the right answer. To the right.
To the right.
So in other words, if it's like 8x minus 2, h is greater than 0. If we substitute it in a number greater than 0, it's going to translate it h units to the right. If h is less than 0, it's going to translate what?
To the left.
Right. Translate h units left. All right, last one, 4, B. Notice that's kind of opposite of what you'd think, because if it's a negative number, it should go, if it's a positive number, it should go to the, well, if it's x minus, it should go to the left. If it's x plus, it should go to the right. That's kind of odd.
Well,
All right.
Sorry. Well,
Good.
it makes sense because
Yeah, what Elena said totally made sense, because you have a negative number in there. You have, or
Yeah.
you have a positive number you substituted. You have a negative number you substituted.
because h is greater than 0, so then it's a positive number, so then it goes to the right.
Okay.
Yeah, that's the part that makes sense. And then like the thing that makes sense. Oh.
All right, here's what I'd like you to do. Here's what I'd like you to do. Oh, we don't consider B negative in Algebra 2. Sorry, that's pre-calc. Pre-calc. I know my targets. All right, I would like you to just take a look. We are only going to consider B to be a positive value in this class. It's just too confusing, and we lose students, and we're just not at a mathematical maturity yet to understand B's negative role. All right, so when B is greater than 0 is all we're going to consider for this one. So I'd like you to look at y equals 1/3 x squared. Y is equal to 2x squared. Notice where the parentheses are. That's really important. And y is equal to, I don't know, 1/4 x quantity squared. Here's what I'd like you to do. I would like you to understand this is what b does. I would like just one last sentence about b, and you must use the word horizontal because I'll tell you b has a horizontal effect. B has a horizontal effect. So look at those three equations, compare them to the original, and tell me what b does, and we will be done for today. I made a relationship joke in like 10 minutes. Like that's
Oh, that's a good one. Oh my gosh.
all right. Volunteer. What? I know this is a lot of exploring. Usually you just sit and consume in class. You don't have to think on your own and discover stuff. But you're in honors. You're smart. Okay, give me a second more. Bram, I saw you looked excited. Everybody else looked like I'm not done yet. So. And don't forget today, about 5 minutes away from the last speech and debate informational meeting over in the cloud today. It's fun. Forbes just listed public speaking as the #1 job skill. It used to be even called the soft skill, and now they moved it up to the hard skill list. What's that mean? Something you have to be successful in the corporate world. It's super fun. We have a great time together. Halloween Congress is our first event here at DCC. Play hands.
If we went to the last one, you have to come to this one too.
No, you don't have to come to both. It's going to be well, if you come to it, they're going to take you to the side and start working on like how do you write a speech, how do you make a case. So they're going to choose a really easy topic and just start to go from what is the reason we should be in favor of this, what is the reason we should be against it, which we call pro-conning, just writing the initial like reasons we should and reasons we shouldn't, taking those and making them into like contentions, and then talking about why they're true, the impact, or sorry, why they're true, what will happen if they're true, and how does it impact people if they're true. So basically constructing getting you into your first debate, because we want you to debate as soon as possible. And the topics that the national group chooses are kind of high level difficult, and we want to get you into a really quick, easy debate like next time we see you. The sooner you start debating, the more fun it is. Like football, you can only practice without pads so many times before you want to hit somebody. In debate, you want to hit somebody too, just with your words. All right, I need a question. Darn it, almost caught it too. I need a question. When b is greater than 0, what happens? When b is less than 0, what happens? When b is less... What's that? Oh, that's right. How about this? When b is greater than 1, and when b is between 0 and 1. When b is greater than 1, oh, god darn it, I didn't even leave myself enough room there. When b is greater than 1, what seems to be happening? It seems to be a horizontal what? Compression by a factor of b. And when b is between 0 and 1, it is a horizontal stretch by a factor of b. So horizontal stretch by a factor of b. So to bring it all together and shake it all up, there are two examples on the board right now. I would like you to tell me all the translations for those. As you are thinking about that, I'm going to write something up here real quick. As you are doing that, I'm going to write something up here real quick just to help bring it all together and shake it all up. I got to write it correct. Kind of odd. When b is greater than 1, it horizontally compresses it. Usually when numbers are bigger than 1, they do what? Stretch. And when b is between 0 and 1, it horizontally what? Yeah, but usually when numbers are between 0 and 1, they do what to stuff? Yes, which brings it all together. Y equals a times the quantity x times the quantity, or a times the quantity b times the quantity x minus h quantity squared plus k. What happens? B and h are both inside the parentheses. They affect x values. They do horizontal, either stretches and compresses, or translations. They're always opposite. When it's x minus h, it's kind of weird. It goes to the right. When it's x plus h, it goes to the left. When b is bigger than 1, it compresses. When b is less than 1, it stretches. It's why you'll hear me say a million times this year. It's always opposite inside. A and k, we already labeled those. They are vertical, they are outside, and they follow normal rules. When k is positive, it goes up. When k is negative, it goes down. When a is greater than 1, it stretches. When a is less than 1, it compresses. 30 seconds for you guys as you're leaving, though. This first one, vertical stretch by factor of 3, 2 units to the right, 4 units up. Reflected over the x-axis, vertical compression by a factor of 1/2, 4 units up, 3 units down. I'll text out homework momentarily. Actually, I will text it out at 3:35 because I have debate practice till 3:30 today. Rebecca Anderson.
So A doesn't actually touch the x-axis.
Does not affect touching the x-axis, no. So Rebecca Anderson, before you take off, I have 2 questions for you. Well, they're questions you probably don't want me to ask in front of your the entire class. Yes, thank you. Thank you. Thank you. Don't forget, we'll check them out if you don't have one, and